Let me share my screen. So, okay. So everyone can see my screen, right? Mm-hmm.
Yes.
So, okay, great. So, so today actually is this session is called kind of hands-on. So, basically we will have in our syllabus you can see that we will have a few of this type of course workshop or just sessions. So it's more for kind of students to ask questions to me, ask questions to me, and I will give some examples. Just like in complementary to what other instructors have kind of have talked about in the past few times. Okay. So as I have only learned about R programming basics for 3 times, around just actually 2.5 times. So today is more for kind of more functions, more codes, more coding about R by using R, and just to make it kind of to give you more functions of R and make you get a good preparation for the visualization introductions next time. Yeah, I saw some questions and uh, okay, Austin, right? I will give you the set you as the co-host. Okay, Austin. Okay, you're co-host now. Thank you. And also let me see if how we became let me set US. Yeah, and sorry. So to make it be kind of to make the course be kind of be 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 okay. So I will, if I've heard some noise, I may directly mute the person. But if you have questions, just you can leave it in the chat, and I will see it. I will check it. Because I have a split screen, and also I think today if Peng Tao is not here, Yue will manage that. Okay. But Yue, you don't need to answer. I will answer, but I will do the kind of you can just kind of
Okay.
let me know, okay, if there are some questions if I didn't respond. Okay, so and let's start. Okay, so we don't have a lot because it's lunchtime and we have relatively intensive introductions today, just for kind of just give you more materials and try to revisit some of the kind of what you have learned about. Okay, and also we will give a few resources. Okay, and to make you have a better preparation for our programming. Okay, and let's just clean this, and we see here, and we just don't use this command frequently. Okay, rm list rm remove list equal to ls. What is ls? All the variables in the current working space, right? If you use this, that means you remove everything. And the control L, you will see nothing here. So it's just like an empty R, okay? So we have talked about in the past days, 2 days, we have talked about some basic R programming, including like scalars, so, and also some basic operation, and you see here, and the equal symbol, and is kind of the same to the left arrow, okay? So we will get this is a square root of 6.25, and we can create a vector and create a vector by some tricks so to enable kind of a sequence, right? And also we can create a vector, 2 small vectors, and link them together. Link them together. And also we can create, so I think yesterday Dr. Shatao talked about some like C bind, R bind to make them into a matrix, right? So we just don't just directly print them as this is a matrix, and use C bind them as column and bind them into the rows to make it a bit more straightforward. I may add one more variable. So here is you make a C band, you see you will get 3 columns since you bind 3 vectors, and you use R band, you will get 3 rows, right? And also we use this to get a certain sequence, right? From whatever to whatever value as a start, whatever first value as an end. So if we do, and this is we can do complete operations, right? But the operation is definitely with some rules. Like if you put a bracket here, so it will do first do the plus and then do the multiplication. Otherwise, it will do kind of from left to right, and also multiplication go first, and the division go first. And we'll have some. We also have some other operations. And here is 2 to the power of 3. Okay. I'm not sure if you we have introduced about this. So it's 2 to the power of 4 to do the kind of enable you some kind of quick computation. Okay, and also for the when we want to divide something, so here is 2 operations to get the kind of quotient and so and also the remainder. Okay, and you can see that if we do it here. Yeah, so the remainder is 1, and if we do this, so quotient is 2. Okay, so also we have some. These are just a list of simple operations. So if you put x to a vector as 110, and you plus 2 minus 2 multiply 2 divided by 2, and take the power of 2 divided by x, and also 2 to the power of x. It's kind of just a kind of directly applies these operations to each of the value. Okay, and also if inside the value there is a NA, that means not available. So it's just a kind of a null kind of a value without any sense. So, but sometimes it's possible. For example, if you want use 1 divided by 0. Oh, this is infinity.
Was like not even many times.
For example, you use your log -1. This is NA. Okay. So this is NA. So and once you get NA, so NA will operate to any operation to NA, NA will be NA, except one operation we will see later. It's a logic operation. It's kind of ask if this value is NA. Okay, so there's a way to deal with NA. It's kind of if you put any value, if any operation on NA is NA, then you have no way to deal with it. But if you do some kind of but luckily we have one. Several operations can make it. Okay, and also so a lot of functions enable. I think yesterday I'm not sure if Sha mentioned about the mean function. So for example, if mean just give you the mean, the average. This one, if this is a mean, and 1 to 10, right? And also there are 2 functions. It's another function called sum. So it give you get the sum of them. Okay. And then one thing is, if you have an NA, what will happen? If you have an NA, what will happen? There will be NA. The reason is, if you put an NA into the function, sometimes most of the times that if the function take all the values in, it cannot handle NA. So what it can do is normally there is a option of the function. So kind of people are keeping promoting it. So if you select NA.rm, which means remove all NA values, so it will be can be conducted. Okay, just small tricks. Okay, and also yeah. So to make this be convenient to everyone, so I may copy paste this in the chat, so you can copy paste. This is not very long. I mean, copy paste everything I talked about today to the chat. You can copy and paste to your working directory. Okay, but be cautious about this for first line NA list equal to LS. So that will delete everything. Okay, in your current your current working space. Okay. So and then I may have some examples. Okay. Oh yeah. So then later on we will have the kind of the operations on the vectors of the same length. You can see if they are same length, xy is what? Xy is 110, x2 is 42. So if they are of the same length, we can do a lot of we can just smoothly do all the operations on them. Okay. But if we have data of different lengths, what it will do. It can still enable you to do some operation. So the logic in R is it will do, for example, if you do plus, it will first so kind of x is 1020, x2 is 13557. And when you plus these two, so the first is 10 will plus with 1, 20 will plus with 3, and then 10 plus with 5, and 20 plus with 7. It's like this. So we'll get this result. So it kind of the order is like if x is kind of shorter than x1 is shorter than x2, what it will do is it will first do the matched kind of position sum, and then it will kind of, it's like you when you do the plus, it's more like it's x1 and another x1, and then plus this with add this to x2. Okay, so this is the operation. But so for sometimes you may have kind of the axis, the length of x2 is not a kind of a certain times of x1. So well, some of them they will still show a warning, but still give you some result. So the way is sum it. The rule is like sum these two, 1, 2, and 1, because in total you only have 3 elements there. Oh no, and here is this 2. 1, 2, 1, and the other is this. So just like sum 1 to 1, 2 to 4, and 1 to 6.525. So that will then for your practice, you can, if you want to practice about the operation, so there is a good, interesting thing is called the 6th challenge. So basically the 6th challenge measure what is you can use any operations, make the equation true using common mathematical operations. So you can use any kind of, you can't introduce any digits, but you can introduce any kind of operation. And this is a good thing is you can you can introduce the factorial product. So here is kind of the answer, but if you're interested, you can solve this by yourself. So I just give you the one, here is a YouTube link about the challenges, and just give one example. So if we do factorial 0, and it will give you 1, and we do the sum, it will be 3, and then if you do this, you will get 6. Okay, so this is about the all basic operations. Okay, and then let's talk about the some further things about the, let's see, here is sorting, and then where did I put the oh, here, sorry, I missed this line. Yeah, so here is very important. It's a help.start, and what it will help you open so a website. Okay, so this is about this should be what we installed inside our machine. It's not about in our laptop. It's not kind of an online part. Okay, so and there is a search engine. So and you can go for read some functions. It's kind of this math functions, and also there are some other graphs, and also there are some Iris is also about some functions, some bad it's kind of with certain functions here. And this is about which package contains it and what is the function name, for example, sort. We'll talk about this later. And math. So go for math, you will see a lot of math function. For example, if I want to find sine or cosine. There's cosine function. It's not stored in math, looks like. But there will be some place store it. Okay. So we'll see you can check this for check different functions. It's like a function list. Okay. And then we'll talk about some operations to vectors to array data. Okay. So the first thing is when you get array, so what you want to do is sorting. Okay. You can sort X. So basically it will sort it from like 1, 1, 3, 3, 5, 5. And the rev sort. So kind of we can reverse the vector. Okay. And I think sort is there should be some, if you use this, we can, oh, where is it? Here we go. Okay, here we go. Here's the sort function. So you see here, they have a decreasing equal to false. So if you do sorting by using decreasing, so if we do sort x, decreasing is true, or decreasing is true. True means 1, or decreasing is 1, or decreasing is 1 is not good. So here is decreasing should be true. So you will get, so here f is false, t is true. This is like a pi encoded in R. It's like exp, exp1 should be. Oh, sorry, exp1. This is like e. So and pi and f and t. These are some constant encoded in R. Okay, and this is a sort x and rev sort x, and also we can sort x and with decreasing. So gets a decreasing to 2, yeah. And also we can order x. Order is another command. Sometimes it's very useful. So what does order means is that it will return you the position of x. It's kind of return you the position, the index of x. That the first one is the index of the smallest value, the index of the second smallest value, the index of the third smallest value. It's like you sort x, and then from first value to the last value, in the sorted x, you find the position, the index of it in the original x. So for example, if you do x order x, you will get the same thing of sort x, but it will give you the kind of the order of it. Okay, and another one is called rank x, but a lot of people read this don't use it. Okay, rank x is what? It's about for this value, what is the rank of it in x? It's like the value of the kind of the rank of the key, kind of the value in the first position, second, and the third, from small to largest. Okay. So if you use x order x, you will get something meaningful. But rank is just shows kind of who is the kind of the largest one. Okay. Who is the middle one? Who is the largest one? Who is the smallest one? Okay. Any questions about this? Okay. So, but later on, if you just try more cases, you will find what happened. Okay. If you put more values here. So you try more cases, you'll find, oh, this looks like this, but order x is, they are all the same from the value is all the same from 1 to 7, but they have different meaning, definitely. Yeah. And unique is a command that we use to only take unique values. Okay. So for example, there are duplicated, like duplicated 1, duplicated 2, duplicated 3, 4, 5, 6. But if we do it, it's returning us duplicated value. And the more interesting thing, if we put the 6 in the beginning, the order is what? It will be the order of the first value has been seen, kind of we reach in the vector from left to right. Okay, so here is the 6, then 1, then 2, then 3, 4, 5. Okay, and the unique is kind of, if you do unique to a unique to a vector, to an array with only unique values, it will return exactly the same thing. And another one is about table. So table is a function that kind of returns a count of each element in the array, in the input. So it will return you there. This looks like what? This looks like a kind of a 2 column. Actually, it's not. It's just 1 column. So we like this to store this into a variable called AA. So we see if A is a matrix, this should have a dim, but it's no. This is only one. This should have a kind of fixed dimension. But we do the length A, It's just a 6, okay? And that means this is it's an array, okay? It's a class. It's just a table. Yeah, it's a table. So, but this see if they have a number of columns. No. Number of rows. They have no number of rows. 6. But this is how it starts. But actually, A is what? If we do A1, it's 4. This is A1. This is A2, A3, A4. We check names AA. You found this is actually their names. Here is what, sorry, so it make you feel a little bit confused, but here what this tells you is, if you use table of this command, so it will return you, there are 4A, 32, and 13, 14, 15, and 26. And actually, this is the value of data. For example, if you A plus 1, A plus 5. So first, this row won't change. Actually, this is their name. This is their name. So for any vector, or any array, so we create, for example, like this array. So if X is this, we can create X as we can put the name of X. For example, we can put the name of X. We put names of X as this. When we return show X, X will looks like here. Okay, this one. Okay. If we put names as X to 1 to 7, it looks like this one. Okay. So similarly, A is just an array, and with the name of 1 to 6. Okay. So this just will return you the count of each number, and with each number as a name. So similarly, if we do it for a table of another vector, it's kind of like here, like this one. So if we put multiple A in and multiple D in, okay. So it will also generate a vector with the count of each of the element inside this input vector, and with each of the element as a name. Okay. So any questions about this part? Oh, sorry, I stopped share. Only click that. Here we go, keep share. Oh, great. So then we'll talk about some further computations. I think it's about we can do this is called a seq. It's how to generate. It's how to generate kind of a sequence. So here is the first one is from. Let's go from some simple ones. Okay. The default one is if you do seq 0 to 10, it will generate the sequence that with exactly the step as 1 from this value, first value to the last value. Okay. But if here we do seq from 0 to 2 pi, and the length equal to length dot out equal to 100, so that means with this setting, it will automatically generate 100, just 100 vector, a vector of the length exactly equal to 100, and each of them have an equal step difference. Okay. And also, if we do it from 0 to 2 pi, and the pi equal to 1, so definitely 2 pi is like around this value, but since this value is not kind of is a floating number, so it will be kind of be omitted. And because this seq is we set pi equal to 1. And another command is wrap. Wrap means making replications. So for example, if we put n equal to 10, and the wrap 0n will generate a vector that with replication with 10 replication, n replication of replications of 0. We can also do it to generate more complicated things. So kind of to generate certain kind of patterns like that. So, but this is not so kind of necessary because we can make it for 6 directly for 6 times. But if put this another one here, so we will first replicate 1, 6 2 times, and then add link 10 and replicate it 3 times. It's enable you some flexible optimization, and also another. Then we'll talk. So any questions about till to now about the operation on sequence and the basic operations? Okay, I think the more important thing is that if you, actually I can say this earlier. So today's homework, there's no exact homework for this workshop, but I may make a kind of a question for everyone. So think you don't need to send this back to me, but you just think and ask your professor and keep this in mind. So you may tell him or her that okay, you're learning R programming these days, and you can ask your professor in your summer research and about okay, if they have any questions in the lab that can kind of they think that can be kind of or any data they are dealing with in the lab, they think okay, you can help to kind of work on the data to get some interesting questions and or visualization generated and can help them a little bit. So just to see, so the reason I want to ask this is just I want to give you some let you have some possibilities to utilize what you have learned here in your daily research. But just think about that and go to mine this possibility by yourself with the professor. Okay. Mhm. So and then we'll talk about NA. NA means so sometimes it's kind of you will get the kind of a non-applicable results or kind of not valid operations. For example, if we do square root of one, so of -1, and square root of this is square root of this is valid because this is just delete this one. This is about complex analysis. So okay, so and then we'll talk about logical operation. Logical operation is a very important component in programming because sometimes it may help you to because when you do programming, for example, if you do the analysis like we do some analysis to the values that satisfy a certain kind of condition, only to the values satisfy a certain condition, and so it will be kind of definitely be you may need some logic operation. Okay, so here the kind of simple operation just like a smaller or greater. It's like here. So if if log 15 is smaller than 2, so this means log 10 means this is not log e, it's log 10. So and log 10 and 15 is smaller than 2. It's true. Yeah. If it's smaller than this means whether it's smaller than 2. Actually, if we compute it, it's 1.17, so it's smaller than 2. So this is true. So it will return you kind of this is the operation. This is the operator and it's smaller. And if this is smaller, it's true, and it returns this value to AA, and it will give true value. So if this is, and if this greater, that if since it's smaller, it's definitely cannot be greater. So it's the return is false. Okay, and also we can do this operator to a whole vector. If 1, 3, 5 larger than 2, only second and third item, third first and third second and the third entry is larger, they are larger than 2, right? And this is a simple operation. So 1 to 4 and 4 to 1. So if the so the left vector is greater than the right vector, only the third and the fourth entries do kind of do greater than 3 is larger than 2, 4 is larger than 1. So this will get false, false, true, true. Okay. NA equal to NA. So equal means what? Equal is return you the whether these two things are equal. So it's not a one equal symbol, it's two. So this double symbol means if you compute whether two things are equal. Okay. By what I remember, I think EQ is do the same thing. Oh no, not. Sorry. So 1 not equal to 1 equal to 1. Okay. But if you compute it for NA equal to NA, always will return you NA. NA larger than 2, it will be NA. So a lot, like I mentioned, most of the operations on NA will be NA. But there's one kind of one different case. This is for about how to handle NA. A star NA. A star NA will return you kind of A star NA will return you 1 because NA is NA, so it will return you true or 1 kind of and for NA, but false for all the other values. Here you say that true and false are two values, right? But if you do, this actually is a kind of a logic result is true, false. But actually it can be with some operation. For example, you multiply 1 with that. True will be, you can say true is 1, false is 0. Or you can say if equal to 1. You can say true is still true. If this is equal to 2, definitely no, not. So actually in terms of operation of computation, so true is a variable equals to true. When you put it into a kind of a certain computation, calculation, so it will serve as a value 1. Okay. For both type and value. So how to test the equality for both type and value? So first, if the two things are of two different types, if you, for example, if I understand you correctly, so if you put a character here, and if this equal to 1, whatever they will, oh, wow, this is same because I never did this test before. Okay, I've never done this test before. Oh, this is so kind of convenient. Okay, so and so how to test the equality for both type and value? Okay, so if you want to both, so this is what I'm doing. Like I mentioned, there are different ways to do the same thing. But for example, if I want to do the if you mentioned this about the type, it's like a character or numeric. So what we will do is, if this is this is numeric, so we will use this to test whether it is. And also, for example, if I have two values, a1 equal to 1 and a2 equal to this one. Okay, so if we just want to test if their value are the same, so we can definitely test if a1 equal to a2. But this is a kind of it may give some biased result, like one is a character and the other is a numeric value. Okay, but if we do this, if like a type class of a1 and let me see, I think the mode should be mode of a1, right? Character mode of a2. If these two are the same, if these two are not the same, so we can tell their mode or their type are different. Okay. So, but there are more kind of way more. We'll mention type. I really don't. I'm not. No, I don't know what is the details of what do you mean for type. But there can be different. In general, there have different type of things like array, like a matrix, like this is about the kind of the data type, and also this can be like a character or numeric. This can be the data mode. So, but we'll do the analysis. So sometimes, like I mentioned, so sometimes are like here, like are enable enough flexibility, for example, to do the kind of sum. You can even sum the data of different lengths, or even this. So if I do this, so if I do a matrix, 1, 2, 3, 4, 5. Okay, 6. I'm not sure if I can do it. It still can do. You see, we use 5 values and make it build into a 2 by 3 matrix. Oh, it looks like this. Okay, this is how it looks like. Even if there's a warning, but they get some return. But then if we want to plus something, 1, 2, it will first one plus 1, second plus 2, first one plus 1, then plus 2, first one plus 1, second plus 2. Yeah, and then what we may do is, oh, it can always give you some result, but if you do this, it's kind of in a very kind of irregular way or kind of a less controlled way, so you will feel confused about the result. It's kind of, it can still do the operation, but the result doesn't mean a lot. It's not a lot of meaningful, have a lot of meaning. So what I really recommend you is that even R enable a lot of kind of flexibility and to make your kind of programming can be frequent enough and without kind of a lot of bugs. But so what I recommend you to do is just to make your kind of write the functions or write the operations be as clear as possible. Okay, so to avoid this kind of strange cases. Yeah. Okay, so I see 2 questions. First, the difference of class and the mode. So like I think Sha mentioned this a little bit yesterday. So mode return you the, you can see here. So we just do this as example. So mode returns you the kind of the type or storage mode of an objective. It including integer, and it's included, normally it will be numeric, and also the, you can see here is let me see, so returning, yeah. So integer and double are returned as numeric, and the functions may return as a function. A symbol is called node name, and the language. Oh, I think it's somehow may return as the character. So mode is just about the kind of it's just about the data, like it's called a storage mode. For example, if this is character, we can do character operation on it. If this is a numeric data, we can do numeric operation on it. So for example, mode of x1, mode of a1. A1 is a character, and so we want to A1 plus 2. There's no way to do the kind of numerical operation. We can only do the, but if we paste, for example, if we paste A1, kind of if we do some character, we will introduce some character operations later, but if we do character operation, we can definitely apply to A1. But the class of A is about the storage structure of A. Oh, sorry, you mentioned class. Let me see, class. Oh, let's see, class. Okay. Class will also we return the same thing. Okay, let me see. Code by numeric. See what this it is. Codex +1. What is the mode of it? Let me see. Mode is a call. So class is this. This is weird. Because I haven't used this class before, so let's see what is called. Parse true for the expression. Oh, great. So you can use mode to set how functions interpret it, and versus classes actually data type. Oh, that's clear. Yeah. Thank you, Rishi. No, this is not. This is substituting and coding. So this is not about that. Okay, so we can leave this for, yeah. Thank you. So I think we can leave this for further discussion, because since like I mentioned, there were so many functions, but normally I don't use class actually. So I haven't mined this before. So yeah. So and then let's talk about the characters. Okay. So, but good questions. So we kind of, this is commonly happen to R. So when we do the programming, so sometimes when I check my students' code, so or other people's other people's code, I want to use some kind of modify them. So they may use some kind of functions I don't know, or certain expressions I don't know. So but kind of everyone have your own style when you do programming. So but like mentioned, so they are for the same goal, you may have different ways. Some people may use the other ways, but it's always good to learn some new things. Yeah. So very good discussion in the chat. Yeah. And thank you, Rishi. And then let's go further for our, I think I have to done this part. So it's NA, we have done this, okay. And there's some other operator is why is this is in. It means it can test whether the of something in the left is in the in another object in the right. So for example, put a array of 1, 3 in the right, in the left, and we test whether it is in this 2, 3, 4. It's not, okay. And then it will return you kind of the logic of length 2, kind of is if to return tell you it will tell you whether 1, 3 is inside of the array in the left. And the same thing, if it's similarly we can do it whether it test it whether in the array of from 1 to 4. And similarly we can do it to reverse the side, and it will return you a vector of length 4. So it will tell you whether 1, 2, 3, 4 are in 1, 3. Okay. And any may return you kind of if any of this is true, it will be kind of true. Okay. So like I mentioned, so there are multiple ways to do the same thing. So for example, if you don't know the any of this any function, so okay, if we can let this equal to 1 and then sum it. And if this is larger than 1, larger than 0, okay. So this may give you exactly the same thing as any, okay. So this tells you what? Tells you, oh, this equal to t. If any of them equal to true, right, there will be a true, right? And you just do NA.rm is you just sum them and remove all the NA. And if there is at least one true, the sum will be larger than 0. So larger than 0 means any of them larger than 2. Okay, these two are the same. Okay, it's just different ways to get the same goal. Okay, and then we have some which. Yeah, which function is important in kind of the kind of extracting the indices that satisfy a certain condition. So for example, if we put here which is vector is false, true, true, false, NA, so it will return only the true kind of results. So the indices of the true. If we put a vector is from 1 to 20, and we want to get the which indices are larger than 10, get which this part are larger than 20. Here. It can help you us to extract the indices that satisfy certain condition. And identical, just compare if two vectors are exactly identical. Okay, so those are non-identical. Okay, this is the operations to the kind of sequence or array and the logic and also sorry, these are logic operations. And the last part today is about some character operation. So we can set a character, a vector of multiple characters. So like we talk this mode, this character. So if we put one, like I think Sha introduced the list yesterday. List is a different story, but we store it in like a C what using C function, will generate an array. So and for this type of data, so if one vector, if one element inside of it is a character, then it will automatically change everything to a vector. See here, all the things are changed to vector with this quotation code symbol. And here, if we just put if we remove the first element of a character, then everything this is will be a numeric. Okay, got my point? So if we just, the reason is for the vector for array, so it will have the same, all the values will have the same mode. Okay. And NA is what? NA is can be in either because it have no kind of a property, it's just NA. So it can be either in a character array or in a kind of a numeric array. Okay. So and here is an example as a gene, an example of a gene list. So when we do I think a lot of you are working at medical school or at biological department. So what we are dealing with is a lot of genes. Here is just some list of some genes. So you see their name. So they have some similarities. Just from their name, we may guess. Okay, so those CD initialized genes may have certain similar functions. This HK1 and HK2, they are highly similar. Actually, they are about the same. They are about just the same different isoform of same same enzyme. So we can do a little bit search of it. So you see that this is HK gene. It's called hexokinase, and it has certain functions. And it's a phosphorylate glucose to produce glucose 6-phosphate. Okay, it's kind of some terms is relatively new to some people. So, but it's basically you can consider glucose. It deal with glucose and produce some downstream chemical. So it's just to do some catalyzation. So this is HK1, and we search HK2. It's also the same gene. It's also the same function. They are just different isoform. So sometimes when we want to extract the gene, analyze the genes of similar function, we may deal with their kind of the property or the characteristics of how they name it. So for example, SLC gene is a class of it's called a solute carrier family. Okay, so there are a lot of, if we search for this SLC or solute carrier family, you see a lot of SLC genes. We can see many SLC genes here. If you click, this name is not as, this is just kind of, this is another name of it. It's with some SLC, but there are a lot of SLC genes here. So, and multiple pages, you see a lot of SLC genes. So this is a big family. So sometimes we want to analyze the property of those genes. In our analysis, we need to extract all the SLC genes. How to do it? So there are several ways. So first, so if this is our input of the data of the character, we can do some operations to do kind of to modify the characters and to extract those. Yeah. Oh yeah, great. So and here is the, you can see here. Let's do some modification. So to upper means we can make the kind of the case to the lower case to capital case. Okay, from ABC to small ABC to large to capital ABC. Okay, and to lower is to lower case. Okay, and n char return you the number of characters in each kind of in each string, because this is a string, right? We call it a string data. the number of characters, even it's the mode is character, and but it's just it's a number of n-char means the number of characters in each string inside each array. Okay, here is a bioinformatics with 14 characters, and here SLC2A1 with 6 character, SLC1A2 with 6 character here. Okay, and substring, it will kind of do the get a substring from a position to certain position. For example, January 7th. So we just want the January information, so the month information. We just take the first 3 kind of character, and also we do the substring of gene list. Original gene list is this, and also we can do substring of 4 to 5. Looks like here, and also interesting. 3 to 1. There's no way to do this in this way. Okay. So, but we can do it 4 to 5. So a lot of them don't have values because their length is only 3. Okay. So, and also another one is if we do substring here is 0, 7. But like I mentioned, this is a character mode. So if we do operation of the kind of plus, we cannot do any operation on it because this is a numeric operation. But we can make it be as numeric. We can put it and change it 0, 7 to 7 and do the numeric analysis. Okay, numerical operation. And but if we just extract the first two, the first with JA, and we add the numeric, it will generate NA since this character cannot be changed into numeric value, and we do the plus also get NA. Okay, and similarly we can do to change a numerical vector into a character vector. Okay, and also the next command I want to tell is paste. Paste may enable us to kind of to generate vectors with just a paste strings. Okay, and the convenient thing is sometimes it can help us to generate a lot of duplicated vectors. Like for example, if we wrap 1 to, if we do the if we just here we do 1 to 10, so it can give us the file names from file 1 to file 10. And definitely the files should follow certain kind of pattern. Okay, and if x equal to this, and another kind of another function is gsub. It's just to do the substitution of certain symbols, certain characters in X. For example, if we do gsub of this gene list, and we do sub SLC to what? To SC. Okay. You see, all the SLC were changed to SC, or to change it to AA. It will all the SLC change to AA. Okay, just do a substitution. And another thing is about the little bit more about the more advanced operation is about split. So sometimes you want to do some operation on the character. So you want to edit it, you want to split it. Okay, you split. For example, BBB1. Here was BB1. BB is like this. So split it into, and it will return you a list. This is a setting of this function. To return you a list contains the kind of splitted values. You should use onList to change the list into a vector. Okay, so if you do it, so this just a split it with a separation of this underline. Okay, and this is if you split it by and kind of just this may tell you, okay, it's just split by any separate kind of for any just split it to individual character. So this operation you tell, and unlist it will change it to kind of each character. Okay, and the last one about what we'll talk about today is grep. Is kind of find specific patterns inside of a vector. There are some other functions can do the same thing. A lot of different kind of functions or operations to enable finding the kind of the same pattern or similar pattern. Okay, from a certain pattern from a string. So here I introduce a grep. So it just find the position or the not position, the indices that matches SLC. Okay. So here first, fifth, and sixth. Okay. So we do the gene list, and we do this. We will see it. Okay. And also we can add the distance equal to 0 means enable no mismatch. Normally we use this, but sometimes we can enable some mismatch. Okay. So if the mismatch is 1, that means if we can find the SL, because only 1 is mismatched. Okay. Or even if we put the SC1 here, it will even find SC1 because only 1 is missed. Okay. It's kind of mismatched, I mean. So that's all I want to talk about today. So I put this to the chat again, but I may also further, we will also run this. In the weekend, we will have the GitHub link established. These days, my students are working on some other things, but I will put this in the chat so you can copy paste, and for your feel free to check this in the. Sorry, let me do this again. Sorry, I put it now to everyone. I should put it to everyone. Sort. Oh, it's too long. Sorry. So I may put it into I may save it into R code, so I can send this to you. So example code file. How to get it? Let me see if I can do this. What's the difference between R and R Studio? So let me stop share. So the difference between R is just a general, yeah, R Studio is an editor, yeah. Oh, great, Pontal is here, yeah, cool. Yeah, so Pontal, how can I send my codes here? So send the files to the chat, because when I click file, the only option is about Dropbox. Yeah. So no, R is not like a note. R is kind of it's just a script language, so you can use the kind of it's kind of R Studio is a better kind of has a better interface of R, but basically it has all the same functions. So R they have a console, can have the kind of place to enter scripts and to make the programming. And R Studio also have the same thing, but it may kind of make things be, kind of organize things be, in more beautiful way. Yeah, kind of a user-friendly way. So it's more like a kind of an improved version of R. Okay, but the improvement is not about the function. The improvement is about the kind of the interface. Okay, so all right, so I think we can stop here, and I will let Peng Tao create the a Google link about the scripts today, and we used it today. And also, what we will do is we will create a GitHub link in the weekend, and you will receive that in the weekend. And then later on, we will keep using that, and you can find all the codes and data used in this workshop. Okay.
All right. Well, thank you again for the awesome presentation. Students, make sure you send out that round of applause.
Oh, thank you. Thank you, everyone. Yeah, you're really welcome. And just email us if you have any any questions. Yeah, and we will have the kind of mechanism, as I mentioned, the GitHub link established during the weekend, so the kind of things will go easy. Yeah. Cool. Thank you, everyone. Yeah.
Thank you.
Bye bye. Have a good weekend.
See you.
See you.